So welcome to the tutorial on how to estimate analytical thresholds. In this tutorial, you will learn estimation of analytical thresholds from negative and positive PCR controls, single file import with automatic trimming of ladders and conversion to the STR-validator format, splitting of a dataset into subsets, cropping of data to extract subsets, and plotting of distributions. We start the STR-validator by clicking the icon. Put this to the left and put this to the right. Okay, so the left side I put the R terminal window, and here you can see useful messages and error messages. So start by clicking the workspace tab and the import button. Select a single file and open the input files folder. And select the control sample plot sizing table. Click OK. We want to trim away the allelic ladders, so we check the auto trim samples option and expand the trim options group. And here I specify to remove ladder. All the sample names with ladder in the name will be removed from the dataset. I give it a name. Dataset controls. Click import. Now we want to import the reference for the positive control, so click import again, select file, and now choose the reference positive control file. Click OK. Uncheck the auto trim samples. Instead, check the auto slim repeated columns option. This convert into STR-validator format. Give it a name, reference profile, and click import. So now we have two datasets in the workspace. One with the control data, both from negative and positive controls, and the second is the reference for positive controls. If I select this and click the view button, I can take a look at the profile. The sample name is pos, and the markers are here, and one allele per row. So close this button. The first thing we need to do is to split the dataset into two, one for negative controls and one for positive control. So click the Tools tab and the Trim button. Select the dataset controls, and we would like to keep first all the negative controls. So I type neg, which is a string that is unique and common for all the negative control sample names. Then I change the name to dataset neg. Click the Trim dataset button. Repeat with the positive controls. So we select the same source dataset controls. And now we choose to keep all the samples with the string pos in the name. Change the name for this dataset to dataset pos. Click Trim. Okay, so now we see all four datasets in the workspace. Now we can continue to estimate analytical thresholds, so we click the AT tab. Here we have two buttons to calculate, and the first button using 4 different methods at once, while the second button estimates the analytical thresholds from a serial dilution. And this is not really recommended, but included for comparison. So click the first calculate button. If you would like more information on a method, you click the help button, and then click the calculate AT function link here. So here you can scroll down and get all the details for different methods and also references. Now select the positive control dataset and the reference profile. Here we see a summary that we have 23 samples and one sample in the reference dataset. Click the check subsetting button to make sure that the reference name is matched with the correct samples. So the options here are that mask high peaks. This option is used to exclude artifacts from the analysis. It can be dye blobs and spikes and so on. And this threshold should be well above the actual noise. So I will keep 200 RFU here. Then there is an option to mask sample alleles. And this means that you remove the known alleles from the dataset. And you can specify a range around the known alleles. And I will expand this to 100 data points around the known allele. And I have previously checked that in GeneMapper, this will include both the -1 and -2 stutters. And we would like to mask on a per die basis. The next option is to mask the internal lane standard peaks. This is most useful for very weak samples, so I will uncheck this now. And here we can specify the confidence level for method 1 and 7, and the percentile rank threshold for method 2, and the upper confident or alpha for method 4. And if you want to read more about these parameters, you can go to the help button, and as I showed before. We will just accept or start with the default values here, but they can be changed for a second analysis. Click the Prepare and Mask button, and then select a random sample. This opens a plot window where you can inspect the masking range. Here you see all the 12 peaks represent the known alleles, and the shaded color around the known alleles represent the range which you have chosen to mask. So everything within this range will be excluded from the analysis. And we can check a few random samples to make sure that this range is correct. And perhaps we would like to save one or more of these plots for inclusion in a report. Then we can click the Save Plot button here. Usually I will just uncheck this option to load sites from plot device. This is good as a starting point, but to be more to have every plot in the same size, I will usually uncheck this and specify my own size here. 40 and 20 is usually a nice picture. Then you can also choose to overwrite existing files automatically or not by checking and unchecking this option. You can select the file format. If you want a simple file to include in a Word document, you should select a PNG or JPEG or some common image format. The resolution and scaling can be usually is okay with the default values. Now click the Open button to locate a place to save the images, and I will have a folder here, Outlook Files. I open this one and click OK. Now we can save this by clicking the Save button. Okay, now when we have saved an image, we can continue to actually estimate analytical threshold. The result will be saved in 3 different data sets. One for the actual result, and one for specifically for the method 2, which is the percentile rank threshold method, and then one data set where we can inspect and see which data is actually included in the analysis and not. So I click calculate. Now we'll minimize this plot. Okay, we can do the same thing with the negative control data. So select the dataset neg, and now we don't have a reference dataset, so we leave this drop down here. And again, the kit is automatically detected as the Fusion 6C. We just keep masking high peaks above 200 RFU, but this time for negative control data we uncheck mask sample alleles. And instead we check this mask internal lane standard peak option. And here I will expand the range to 50 data points, because I have seen in GeneMapper that we have actually some pull-up in neighboring channels, and they are at maximum 50 data points from the actual internal lane standard peak. Keep the defaults for the first run, and then click the prepare and mask. Select the sample for inspection, and then we have all the internal lane standard peaks here, and we block a range plus minus 50 data points around this. So actually there is quite a lot of data that we exclude from this analysis here. I want to save one of these plots as well, so I click the save plot. And now STR-validator remembers the settings, so we don't need to change anything here. Just click the save button. And I minimize the plot and click calculate. If we click the view button, we can take a look at the result. We select the dataset neg 80, which is the results for the negative control data. And I will maximize this window. So here you see that we have actually one row for each die for each sample. The first sample is actually making up 1, 2, 3, 4, 5 rows here. First comes the summary statistics for the die within a sample and for a sample, and then finally the global summary statistics here. After that, if we move more to the right, we have the result for the different methods to estimate analytical thresholds. First, method 1, AT1, per die, for the die within a sample, global across dies within a sample, and globally across all data. And then globally across all data, but only for one specific die, for the blue, green, yellow, red, and purple channel. Then we have method 2, a percentile rank threshold method. And here we get the result from the specified threshold that we set before. Then we have the method 4, and finally method 7. Both method 1 and 4 assumes a normal distribution of the noise data. However, method 7 uses logarithmic data. So which method should we choose? Well, we can check the assumptions if we first extract all the data used in analysis. So we go to the Tools tab and then the Crop button, and we select the dataset neg masked data. Specify the target column masked, and then we need to discard values that are not equal to false. That means that we keep all the data that is included in analysis. We have to specify that this is corrected data, and then click apply. We also need to remove the internal lane standard die, because that one is also excluded from analysis. So we change the target column to die, and then we change to equal to, discard values equal to O, which is the ILS die in this case, the orange die. Then click apply and then save. Do the same thing with the positive control data. dataset post masked, select the masked target column, discard values that are not equal to false, click apply, and then change the target column to die, discard values that are equal to O as in orange, and then click apply and save this data. Now we need to go to the result tab and click the plot button in the distribution group. Start with the positive masked data and select the height column. We can uncheck the option to overlay a box plot, and we expand the histogram option group and change the number of bins into 200, one for each RFU in our data. As you remember, we set the maximum threshold of 200 RFU for peaks to be excluded. Click the histogram button to plot the data, and we can look at the data here. The noise distribution for the positive control data have a quite long right tail. The distribution of noise heights is not a normal distribution. Let's take a look what happens if we transform these signals into the natural logarithm. Click the histogram button again. Now we see that this more closely resembles a normal distribution. So this indicates that we should rely on method 7 before method 1. We can also save these images for inclusion in the report. We can change into 20 by 20, which will be nice. And then I append log for logarithmic data, and then click save. I should also perhaps save the normal data, so I click plot again and save image and append norm. Save. Take a look at the negative control data. Select the height column and click the histogram button. This noise signals has also quite a long right tail. I will save this image, norm, save, and then we transform to the natural logarithm. Click the histogram button, and I think this is also a closer to the normal distribution compared to the normal data. So we'll save this and append log and then save. So now we can take a look at the result again. Check the negative, the result from the negative controls first, and scroll to the right, because now we have statistical support to select method 7 before method 1. So the interesting columns here are the global 87, and here you can see that it's around 19 RFU for negative control samples, or very, very weak casework samples. And the dye-specific global 80s are different for different dye channels. Here, actually, the yellow channel is have the least noise, and the red has the most noise. But the most conservative overall here is the global value. If we go to the positive control 80, and again go to the far right, we can see here that the global estimate is almost 42 RFU. But here we can see that actually the yellow die has the highest estimate, and it's actually above the global estimate. So it's not always the most conservative to choose the global AT. And most publications recommend to have a die-specific AT threshold, but it's not always convenient for the workflow to have them. Now we have estimated the analytical thresholds for both weak samples and samples with the optimal amount of DNA. And we have estimates per die channel or also as global values. The final thing to do, if you haven't done it before, is to save the result. So click the save button. Yeah, I haven't actually saved it before, so I get a warning that I must start with the save as button. If you have saved it before, you can just click the save button. I will select the folder to save in and then click OK, then give it a name. I'll give it STR-validator and then AT. Okay, thanks for watching. Now our project is saved and we have all the data we need to continue with the next analysis.